On the evening of September 8, 1994, western Pennsylvania looked calm from the ground. Commuters wound through tree-lined roads, the sun fading into a warm haze above Pittsburgh. Overhead, a silver and blue Boeing 737 traced a line across the sky. USAir Flight 427, inbound from Chicago, nearly at the end of a short, uneventful hop. 132 people were on board. Business travelers heading home, families returning from summer trips, 2 experienced pilots, and 3 attentive flight attendants keeping the cabin comfortable as twilight settled beyond the windows. Nothing about the flight hinted at the mystery about to unfold. The aircraft itself, a Boeing 737-300, was among the workhorses of the USAir Fleet, a reliable, narrow-body jet that connected medium-sized cities across the United States. Its captain, Peter Germano, was an accomplished aviator with thousands of hours logged. First Officer Charles Emmett, younger but equally focused, handled most of the radio calls as the pair prepared for descent. In the cabin, attendants moved quietly down the aisle, securing coffee pots and collecting stray cups, while passengers stretched and craned to glimpse the lights of Pittsburgh flickering far below. To air traffic controllers, Flight 427 appeared steady, descending smoothly along the arrival path to runway 28R. The weather was ideal for a September night. Visibility clear, scattered clouds high above, only a light breeze at the surface. Everything suggested another routine landing in Pittsburgh's busy evening rush. Yet, hidden within the tail of this particular 737 lay a tiny vulnerability no one in the cockpit could see. Deep inside the vertical stabilizer, the main rudder power control unit, the hydraulic heart of the system that moves the tail's small steering surface, held a design quirk rare enough to escape detection during certification from us. More than a decade, similar jets had occasionally shown baffling behavior. Unexplained rolls or yaws so quick that pilots barely had time to react. Investigators had studied those anomalies but found no firm link, and airlines continued to fly the type with confidence. As Flight 427 descended through 6,000 feet, the crew reviewed their landing checklist. Germano trimmed the aircraft, calling out altitudes, while Emmett confirmed the approach frequency. Below, in quiet suburbs like Aliquippa and Hopewell, porch lights glowed as families settled in for the night. The passengers in row after row adjusted reading lamps or pressed faces against the cool plexiglass, expecting nothing more than a smooth arrival. None of them, not the seasoned pilots, not the controllers watching a green blip on radar, not even Boeing engineers thousands of miles away, knew that this calm descent would end in a tragedy that would challenge the very understanding of how the world's most popular jet behaved in the AI. Flight 427 leveled briefly at 6,000 feet as air traffic control guided it toward the Pittsburgh runway. The jet was following a Boeing 727 only a few miles ahead, its wake trailing invisibly through the air. Inside the cockpit, the pilots reviewed the landing checklist, setting flaps and adjusting power for the gradual descent. Their voices, later recovered from the cockpit voice recorder, were calm and professional. At 19:02 Eastern Time, the 737 intercepted its final approach course. The crew expected to capture the glide slope any moment and ride it down to the runway. The weather remained benign, light winds, good visibility, a smooth path ahead. Passengers buckled belts, secured carry-ons, and braced for the last few minutes of flight. Then, without warning, the aircraft gave a sharp lurch to the left. Flight data later showed the rudder, the large hinged surface on the vertical tail, had suddenly deflected hard, swinging the nose and rolling the jet steeply. Captain Germano countered instantly, applying opposite aileron and rudder, but the airplane continued to yaw. In the cabin, drinks slid off tray tables as startled passengers felt the floor tilt beneath their feet. The 737 kept rolling. Within seconds, the bank angle exceeded 45 degrees, then 60. Engines spooled up as the crew added thrust, trying to arrest the sink rate. But the jet's nose was dropping fast, the G-forces pushing everyone into their seats. "Hang on," Germano called, straining against the controls. Investigators would later calculate that in less than 5 seconds, the airplane had flipped nearly upside down. Airspeed shot past 300 knots as it plunged nose first toward the wooded hills of Beaver County.
Controllers watching radar saw the target streak off the screen. In the tower, there was only silence where a routine landing call should have been. On board, the crew fought every inch.
They had no idea that deep in the tail, the hydraulic valve of the rudder power control unit had jammed in an extreme position, commanding a full deflection even as the pilots tried to center it. Training manuals had not prepared them for such a scenario. Until this night, no simulator accurately reproduced the event. Outside, the lights of Pittsburgh glittered just beyond the horizon. Residents in small neighborhoods looked up at a thunderous roar overhead, a jet far lower than usual, engines straining. Some described a dark silhouette tumbling through the dusk, wings slicing the air in an almost vertical dive. At 19:03:25, barely a minute after the first jolt, Flight 427 slammed into a wooded ravine near the borough of Hopewell. The impact left no chance of survival. A column of smoke drifted above the trees as sirens wailed from nearby towns, the scale of the disaster only beginning to register.
For the residents of Hopewell Township, the sound was unlike anything they had heard before, a thunderous roar that ended in a heavy thud. A moment later, the stillness of dusk returned, broken only by the distant bark of dogs and the first wail of sirens. Deep in a wooded ravine lay the wreckage of USAir Flight 427, scattered across a compact area scarcely larger than a football field. The force of the impact had been so great that nothing recognizable of the sleek jet remained. Only a scar in the trees and a faint haze of smoke revealed where it had struck. Volunteer firefighters were the first to reach the site, scrambling down steep terrain with flashlights cutting through the gathering dark. They were met by an eerie silence. The devastation was complete, a reminder of the enormous energy released when an airliner falls from the sky. As more responders arrived, they formed a perimeter, scanning for survivors even as the grim reality set in. Within minutes, news spread to Pittsburgh International Airport. Inside the terminal, families waiting at the gate for Flight 427 noticed a ripple of concern among USAir staff. When the scheduled arrival time passed with no sign of the plane, phones rang across operations centers and emergency protocols activated. Airport fire trucks stood ready, but soon a sheriff's deputy radioed from Hopewell with confirmation. The jet was down, and there were no survivors. Investigators from the National Transportation Safety Board, NTSB, began mobilizing almost immediately, dispatching a GO team from Washington, D.C. Local law enforcement secured the site through the night, illuminating the ravine with portable floodlights so search crews could work safely. By dawn, television crews had gathered at the perimeter, broadcasting images of smoke rising from dense forest, the first glimpse the public had of one of the worst airline disasters in U.S. history at the time. Even as recovery operations continued, questions mounted. The weather was calm, visibility good. There had been no distress call, no sign of an explosion. How could a Boeing 737, a model with millions of safe flight hours, suddenly dive out of control just 6 miles from the runway? NTSB officials knew the answers would lie in the scorched remains of the cockpit voice recorder and flight data recorder, now somewhere in the debris field. For the families, the wait was agonizing. In Pittsburgh, USAir opened a support center, bringing in counselors and clergy. Company representatives expressed condolences and promised full cooperation with investigators. Pilots across the industry, meanwhile, felt a shiver of unease. Although commercial aviation remained statistically safe, the abrupt loss of a healthy jet under perfect conditions was unnerving. Something somewhere had gone catastrophically wrong, and it was up to the investigation to reveal the truth. By first light on September 9th, investigators were threading carefully through the ravine where Flight 427 had struck. The crash site was compact but chaotic, torn branches, scorched earth, and fragments of aluminum scattered among the trees. The NTSB's GO team, led by veteran investigator Thomas Howitter, established a command post nearby, dividing specialists into groups to focus on engines, airframe, systems, and human performance. Their mission: recover every piece of evidence and determine why a routine descent had turned into catastrophe in seconds. 2 key objectives dominated the first days: locating the cockpit voice recorder, CVR, and the Flight Data Recorder, FDR. These black boxes, hardened to survive immense forces, were unearthed from beneath charred soil, their orange casings battered but intact. The CVR revealed calm conversation until a sudden jolt and startled exclamations, followed by a roar of wind, all compressed into less than 10 seconds. The FDR showed a violent rudder deflection coinciding with the upset. Attention quickly turned to the 737's rudder system. This wasn't the first time a 737 had behaved unpredictably. Investigators recalled incidents such as United Flight 585 in Colorado Springs, 1991, and Eastwind Airlines Flight 517, 1996, where pilots reported abrupt rolls linked to rudder movement. The problem seemed elusive, surfacing only under rare combinations of hydraulic pressure, temperature, and pedal input. To probe deeper, the NTSB partnered with Boeing engineers and NASA researchers. They tested rudder components in specialized labs, using hydraulic rigs to simulate flight conditions. Gradually, a pattern emerged. Under certain conditions, the main servo valve in the rudder power control unit could jam or reverse, commanding full rudder opposite to the pilot's input. A slight misalignment of internal slide components,
microscopic, could produce catastrophic results. While this hypothesis formed, investigators ruled out other possibilities: wake turbulence from the preceding 727, structural failure, even sabotage. None matched the data. The rudder anomaly fit every clue: the abrupt roll, lack of warning, impossibility of recovery. Flight simulators modified to replicate the jammed rudder produced motions identical to the data from Flight 427. As confidence grew, safety agencies faced a dilemma. More than 3,000 737s were flying daily worldwide. Grounding them all risked massive disruption, yet doing nothing could leave crews vulnerable. The FAA issued advisories reminding pilots to use opposite aileron and thrust if they ever experienced an uncommanded roll. Airlines began special inspections of rudder units. By 1999, after years of research, Boeing redesigned the rudder power control unit, introducing redundant valves and stricter tolerances. The NTSB's final report cited a jammed servo valve as the probable cause, concluding that Flight 427 succumbed to an uncommanded rudder deflection that forced the jet into an unrecoverable dive. The findings were sobering but crucial. They not only solved a mystery haunting pilots since United 585, but also spurred design changes and training revisions that would make every subsequent 737 flight safer. The conclusions drawn from the Flight 427 investigation sent shockwaves through aviation, but they also paved the way for progress. Boeing's redesigned rudder power control unit became standard on all new 737s, and retrofit programs were launched for the existing fleet. Redundant internal valves, tighter machining tolerances, and enhanced hydraulic safeguards meant that no single jam could command a full rudder deflection again. Training also evolved. Pilots received new guidance on handling sudden rolls or yaw at low altitude, emphasizing aggressive use of ailerons and thrust instead of instinctively applying opposite rudder, a reflex that in rare circumstances could worsen the upset. Flight simulators were updated so crews could practice recovering from uncommanded rudder inputs, an event once thought too unlikely to model. For regulators, the lessons reached beyond one aircraft type. The FAA strengthened certification requirements for flight control systems, demanding rigorous testing across temperature extremes and hydraulic loads. Maintenance protocols were refined, ensuring valves were inspected for tiny internal wear that once went unnoticed. The ripple effects of Flight 427's tragedy helped shape an era of unprecedented airline safety. In Pittsburgh and across the nation, families of the victims worked quietly to ensure their loved ones were remembered not only for how they were lost, but for what their loss achieved. Memorial services near the crash site became annual gatherings of reflection, where names were read aloud beneath the canopy of trees that had grown back over the scarred hillside. Many attendees took solace in knowing that changes born from the investigation meant millions of passengers would fly more securely. Commercial aviation has always learned from its hardest moments, and Flight 427 is part of that lineage. Out of the devastation CIA.
aim a clearer understanding of aircraft behavior, and a commitment to never let such a failure go unexplored. Today, more than 25 years later, tens of thousands of 737 flights operate safely each week, benefiting from the quiet engineering improvements forged in the wake of the accident. As you watch modern airliners lift gracefully into the sky, it's easy to forget how much effort lies behind every safe landing, effort written in checklists, metal tolerances, and the steady hands of pilots trained for the unexpected. USAir Flight 427 stands as a solemn reminder of the people who unknowingly contributed to that safety, and of the investigators, engineers, and families who demanded answers so that future passengers could return home. Their legacy endures each time a jet touches down smoothly, its wings steady, its rudder responding exactly as intended. From tragedy, the aviation community drew knowledge, resilience, and a renewed promise to keep searching for causes, to keep improving, and to make sure the skies remain among the safest places we can be.